In this final modeling chapter, we will explain the theory behind good LOD meshes, the process and reasoning behind loading, and show the revolver's final LODs. LODs are secondary meshes attached to a main low poly, also known as LOD 0, each of whom carries half the geometry as the previous one. LOD 1 would be 50% of LOD 0's try count, and so on. Game engines replace the low poly with these progressively, and the further the in-game camera is, the higher the LOD level, until the mesh reaches the culling threshold and disappears completely. They are only executed once the bake is final. LODs depend on our low poly's UV layout, as they will be using the same textures, barring some exceptions that have uniquely baked textures, mostly for environment and landscape. The creation process is very straightforward. We duplicate LOD 0, make a note of its try count and the geometry reduction goal we should achieve. Open the UV viewer, add a UV checker, enable the visibility of UV seams, and overall be aware of the UVs at every point of the LOD process. If they break and we don't immediately fix them, we will have to rebuild them or start again. To reduce geometry, delete edge loops, weld parts, remove small pieces, etc. Once we reach the reduction goal, we rename our meshes as LOD 1 and carry on with the next one. This is repeated as many times as required until we reach a point where reducing the try count and swapping the mesh for another one is actually worse performance-wise than just leave it be. Each engine and project has a different lower limit. Hand Showdown, for example, has around 300 trees as the limit for what we consider the last LOD, before culling the mesh completely from rendering. Any mesh lower than that try count simply doesn't have LODs. To quality assurance the LODs, export them to Marmoset and apply the same material as the LOD 0. We can also do this inside Blender. If the weapon is animated, we should also check LODs in different poses to make sure they still work. Even with such a simple execution process, there are many things we need to care about to make this on LODs. Our aim with LODs is to reducing the weapon's geometry, while keeping a similar overall look on it over distance. The bigger pieces and elements on our guns should keep their shading and silhouette more or less intact, so as not to introduce visual popping when swapping from one LOD to another. We will focus more on removing small internal or not very visible elements firsthand. We should have small geometric elements like screws baked underneath themselves so they can safely be deleted without affecting the overall look of the weapon. The most important point about LODs is not that they look great, although we should strive for that by any means possible, but that they have less than half the geometry of the previous LOD. Their focus is performance, not art, so it is not acceptable to make LODs that don't reach the 50% reduction just because they look bad. If they do look bad, and they will have to reach a reduction point where there is no alternative, maybe we can tweak their distances so they are not noticeable anymore. My point is, we follow technical constraints first. LODs are usually the difference between first-person weapon models, high try count on a relatively small objects, very dense geometry, and third-person or NPC models. This also applies to animations. After a certain distance, the weapon will always look static. To make sure we don't break UVs, sliding vertices instead of moving them always keeps UV shells intact. Otherwise, if we need to move them, we should check the Keep UVs and Keep Vertices Welded options in Blender. So finally, let's make our LODs. We officially start by making a collection structure to easily keep track of the different LOD stages and polycounts. The first step for each LOD is simply to duplicate the previous one, and then move it to the corresponding collection using M. Dragging and dropping the meshes into the new collection might not work correctly, since meshes in Blender can be part of more than one collection at the same time, creating a bit of chaos in the outliner if we are not careful. Before tackling each piece, we isolate it and take a mental note of its try count and how much we need to optimize it, by dividing it by 2. To make it easier, we can also write this info down somewhere, for example in the object's name. We then apply a checker map to all pieces. While loading, we need to make sure that we don't break the UV setup, or else the textures will not work anymore. This is achieved in several ways. First, by using the checker map, we can easily see when a certain operation has broken the UVs, because the checker will become warped. Second, by making sure we don't touch the edges that have UV seams. Luckily, this is very easy in Blender, since they are displayed in red by default. And third, by having the UV viewer on screen and UV sync turned on. Many times, when UVs are broken, they visibly change. Usually, a vertex suddenly merges with another one across the UV space in a very obvious way, creating a weird triangle that connects several islands. Cylindrical objects are very easy to load. In Blender, we can select every other edge in a ring selection, only it works in reverse. We first select a whole ring by Control-Alt-clicking one of the edges, one that we don't want to remove, usually the one with the seam, and then go to Select and checker Deselect. If we want to select entire loops, not just the ones in the ring, we can go Select again and then Edge Loops. In this case, we also need to select some more geometry in the front cap of the bullet to be able to reduce the geometry without leaving endguns. We remove these edges and now reduce the front of the bullet. When we are done, we exchange the suffix _low for _load1 to give some awareness of the stage this particular mesh is in. These are the basics about loading. It really is a very simple if tedious process, but we need to keep some things in mind. Here is a small recap. First, we make a folder structure and take note of the polycounts for LOD 0 meshes. From a copy of the previous LOD, starting from the low poly, we go mesh by mesh and reduce their polycount to about half. We can usually get away with a bit less than half, since with every load some small pieces go away. Because those got reduced 100%, there is some leeway to reduce the most visible parts of our weapon a bit less. At every point of the process, we need to be aware of two things so as not to break them. UVs, which we control thanks to the UV checker, UV viewer, and visible seams, but also shading, which we control via sharp edges and custom normals. Some sliding operations can cause sharp edges to disappear, so we need to be careful and reassign them before we move on. We can even disable the UV seams in the overlays menu so we can see sharp edges clearly. We go lot by lot until we reach the final point where adding more lots is actually worse performance-wise. That is our stopping point. Finally, we test them directly inside the game engine, constantly getting the object closer and further from different angles to check for possible popping issues, which we can then proceed to fix. After this introduction, what follows are more examples and tips. As you can see, we can always get away with reducing the concave parts more aggressively than the convex ones. The same silhouette principles from the low poly stage apply to the lot creation. Removing bevels is another common procedure during the creation of Lot 1. This can be done by hand, but in this case I use the awesome Unchamfer feature from Mesh Machine, a commercial add-on. Screws that have 3D geometry are one of the first things that go out the window in Lot 1. They are there mostly to catch highlights in first-person view, making flat surfaces more interesting. From third person, they are very hard to see, and thus become unnecessary polygons. On the other hand, the ones that are big or stick out enough from the weapon surface are more valuable, so they stick around a bit longer. In the case of the lanyard ring, we reduce it while maintaining the bigger silhouette. So when removing half of the big ring's tubes, we choose to delete the ones that do not affect the big circle silhouette. We just reduce the tube from 8 sides to 4 sides, which is only noticeable from a really narrow point of view. In the same vein, we reduce the revolver frame more aggressively on the side where silhouette is less noticeable, the top rather than the profile. Here is an example of turning off the seams display to be able to see the sharp edges configuration better. Starting with Lot 2, the bullet's primer area is a good example of reducing geometry while keeping the same shading. Wherever we have custom vertex normals, we might have to go back to the Yavney add-on panel and click Update Vertex Normals to reset their shading. Again, we can get away with extremely low polygon density in areas that are not very visible, like in this case the bullet chambers. Same here, these back faces will only be visible on an extremely narrow angle that is not even considered at a distance, so we delete them. Here is an example of the fast creation of the grips Lot 2 by removing the thinner edge loops. Of course, the grip in this case must follow the geometry pattern already set up by the frame, so both lots match well together. It's important not to load pieces in a vacuum, but be aware of how the parts around them are reduced and make them match. In Lot 2, we remove the little quad strips inside the grip and frame, so now, to avoid possible holes in the mesh, we simply snap and match their vertices manually. Here's an example of the broken UVs that slip past us because of a lack of UV checker. Notice the small thin triangles that appear in another color, which means that their angles are extremely warped. Finally, we export the lots, plus one more I made off camera, to test them in Marmoset with the baked textures. Left to right, they go from Lot 0 to Lot 3. Other than a slight loss on silhouette and detail, as expected, I don't see any issues with them. Again, their intended job is to do good enough at a distance, so this result is perfectly okay. Our focus is that the overall shading does not change much from one LUT to another to alleviate popping. Notice how elements like screws or small pieces progressively disappear or become flattened. And here are the same LUTs in the open position. Remember to test them all in all of their possible positions. Further away from the camera, weapons lose their animations too. Because of this, we can be more aggressive with the insides of the gun in LUT 3, capping holes, removing even more small pieces, etc. Overall, there is a heavier optimization of out-of-view elements, like the inside of the cylinder or the back faces of the bullet extractor. Conversely, elements with an extremely noticeable silhouette, like the recoil plate, are barely optimized along their borders. Even a slight loop reduction would make the piece look really bad in an obvious way. Finally, notice the geometry reduction on the grips, mostly on the less visible vertical silhouette, and how the lanyard disappears in LUT 2. So that's it, our first 3 LUTs are done. In a game weapon, we would usually make 1 or 2 more levels, but for now, this has been enough to explain all the concepts I wanted.